we're going to start one of what's going to be 2 or 3 probably videos on algebra review for geometry, because there are some basics that we need to go over. The first topic is going to be foiling and simple factoring, and we'll get into then more advanced factoring with some future videos. So foiling out. Foiling happens, it's kind of a double distributive property situation. When I have something like x plus 7 that has to multiply x plus 2. Remember, FOIL stands, F-O-I-L, stands for first, outside, must be a D, inside, and last. It's the order in which that we multiply. Now, you don't have to do, some people do FLA-OI or something like that, but I like to do it in that order. So when we're multiplying binomials like this, we multiply the first values first. X times x is x squared. Then the outsides, x times 2 is a plus 2x. The inside is 7 times x is plus 7x. And finally, the last, 7 times positive 2 is a positive 14. And then we just combine like terms. The x squared does not combine. The 2x and the 7x becomes a 9x. And the 14 does not combine. And that's how we get our quadratic polynomial. That's our solution. Okay? So that's FOIL. Let's do another example of that. Let's say I have 3x minus 7 times x minus 4. Let me get x plus 4 just to keep it interesting. We have to watch our signs when we FOIL, but we go ahead and do our procedure. First, 3x times x is 3x squared. Outside, 3x times positive 4 is positive 12x. Don't forget your signs. Don't just write 12x, write the positive sign down. If you don't write it down, you'll forget that it's a positive, and you'll make mistakes. Inside, negative 7 times x, negative 7x. And finally, last, negative 7 times positive 4 is negative 28. And when I combine like terms, I get 3x squared. The plus 12x minus 7x gives me a plus 5x minus 28. And that's how we FOIL things out. It's really just a double distributive property. Okay? You're multiplying the 3x into both terms, you're multiplying the 7 onto both terms. But that's how it works. Some of you may have learned this through the long multiplication method. It's doing the same thing. If I have, say, 2x minus 5 times 3x minus 2, if that's what I'm trying to FOIL, multiply out, some people may have learned this way. Write it 2x minus 5 times 3x minus 2, and then we multiply the negative 2 times the negative 5 is a positive 10. The negative 2 times the positive 2x is a minus 4x. The positive 3 times the negative 5 is a minus 15x. And the 3x times 2x is 6x squared. And then we add, so kind of like the way that long multiplication works. 6x squared minus 19x plus 10. Really, it's the same thing as FOIL. It's just a different way of organizing it. If you know how to do FOIL, you don't have to do the long multiplication thing. The long multiplication thing will come in handy when we have bigger polynomials in Algebra 2 to work with. It's not going to really be necessary in geometry. So that's just an alternate method. And again, this is just fancy distributive property is really what it comes down to. Most of you probably are going to do that by FOIL, and that'll be just fine. So that's multiplying polynomials. And I think most of you are pretty comfortable with that. Factoring is where things get a little bit trickier. Let's start factoring by the simplest type of factoring, where I have something like, say, 2x minus 4. We have to look for a greatest common factor and pull that out. So when I have a polynomial and I'm looking to factor it, I look at all the individual terms and say, is there something in common? Is there a common factor I could divide by? Because remember, factoring is a form of division. There's something I could divide by and still get all nice even terms here. And obviously, these both have 2 as a factor. So essentially what I'm doing when I'm factoring here is I'm dividing everything by 2. So I'm going to pull that 2 out. This is distributive property backwards. Basically what it's saying is 2 times what is going to give me the 2x plus 4. Well, how do I figure out what? I divide each term by 2. That becomes an x. Negative 4 over 2 becomes a minus 2. And if I redistributed, I'd get right back to what I started with, which is 2x minus 4. Factoring is distributive property backwards for simple polynomials. So if I have something like, for example, x cubed minus 3x squared plus 2x, what's the common factor? Well, when I look at those 3 terms, they all have an x in common. Just one x. This one has 2 x's, this one has, so I got 1x here, 2 x's here, 3 x's here. The most common is just 1 x in common. If I take out more than 1x, I'm going to wind up with negative x's. I don't want to deal with negative exponents. That's a pain. So x is my common factor, and what does that do? That reduces my exponent by 1 for each of these. That's x squared minus 3x plus 2. And if I FOILed it back out, I get exactly what I started with. Now, we're going to be having to do some of this type of factoring. In fact, we're going to get some even more interesting factoring. We're going to get some factoring that's by grouping. So you have things like 5x minus 15, or let's say 5x squared minus 15x and make sure I do this right, plus 9x minus 27. Okay? Sometimes when I see 4 terms like that, what I do is I group the first and second, the third and fourth, because they don't have common factors for all of them. But these 2 do have a common factor. These both have a 5 in common and an x, so I can pull out a 5x. When I pull out that 5x, that leaves me just an x here. Negative 15, negative stays. Negative 15 divided by 5 is 3. X divided by x, the x goes away. The plus sign is between the parentheses, it stays there. The common factor between 9x minus 27 is a 9. 9x divided by 9 just gives me x minus 3. Now, both my terms, my factors, have this x minus 3 in common, so I can actually pull that out. When I pull that out, I'm left with a 5x plus 9. That's factoring by grouping, and that's one way we handle things when we have 4-term polynomials like that, is factoring by grouping. That's going to come in really handy when we're doing more advanced factoring. Let's factor just a couple more simple polynomials, and then we'll get into, in our next podcast, factoring quadratics and the quadratic formula. So let's just do some simple greatest common factor factoring. 24x squared minus 16x. What's the greatest common factor? Well, when I look at that, the largest number that both goes into 24 and 16 is an 8. The largest number of x's that goes into both those is 1x. So 24 divided by 8 is 3. X squared divided by x is just x. Minus 16 divided by 8 is 2. X divided by x cancels. And I factored. And again, we can check that by simply distributing back and seeing if I wind up with what I started with. 8x times 3x is 24x squared. 8x times negative 2 is 16x. Yes, I confirm that that works. How about if I have 75x cubed minus 100 or plus 100x squared? Again, I have to think about what my common factor is. Between 75 and 100, that's 25. X cubed and x squared, the largest number of x's that is common is 2. 75 divided by 25 is a 3. X cubed over x squared, that leaves 1x there. 100 divided by 25 is 4. X squared over x squared cancels out. I'm done. My parentheses are a little too far over. We can fix that. And I factored. So that's just basic factoring and basic FOIL. These are both skills we're going to need in Chapter 10 and in Algebra 2, so it's a great review. All right.